So I will try to speak as slowly as possible, although it's a challenge for me. I usually speak very fast, but I will slow down so that you can fetch whatever I would like to transfer. So first of all, thank you for the invitation to be attending this event. It's a great pleasure. I was first saying to Volodymyr when we started talking about this event that it would be a great pleasure to host it and obviously be a sponsor of this event. And it's a very good thing that we can talk today to an academic or scientific community, because there are many ways that HP may provide some forward-looking visions or statements with regards to the scientific community, and we support it in many ways. And my presence here is an occasion to let you know that there are things that can be done with HP today that are worth having some thoughts about. So again, my name is Philippe Trautmann. I am the European Sales Manager for HPC and POD. And I guess I will have a later talk, I guess Friday morning during the conference, but I just wanted to give this short highlight about what HP is doing in HPC. Is my English okay for everyone? Just raise your hand if it's not okay, if I'm too fast again. Just want to be listened and understood. Okay, so let's move on. The first comment that I have for the scientific community that is here is that HPC is all around us these days. As you see on this table, we are serving many different markets in terms of our products, our software, our services. And what I want to say here is that the scientific community is a big contributor in all these vertical domains. And we know that there are challenges today that only you can solve in order for our vertical segments to be working efficiently. So let's first move on to engineering manufacturing. It is by far one of the most increasing demands that we see on the HPC market today. If you look at all the automotive, aerospace customers, they have insatiable demands for HPC resources, and they need to be very creative. For them, it is not about the algorithmics, the best system that is there. It is only about time to market, and time to market is the only measure that they are taking. So sometimes they do buy clusters because simply a component, a car, an airplane could be available 6 months or 3 months earlier than scheduled. If you look at the Formula One today, the Formula One is a very interesting example. Formula One teams do computing on the spot. So that means that they take a car to the track on the trial on Friday. During the night, they compute the results. They manufacture the new component and they install it on the car Saturday morning for the next week. So this is the kind of challenges that we see today. If I look at a customer of ours, which is Airbus don't care at all about the infrastructure. The only thing they care of, they want a service. They want their engineers to be able to run their applications. And that's the only thing that matters. That's why you scientists should not be only looking at the best performing algorithms, but also at the usability of what you are thinking of. And it is a very important statement that we are making to the scientific community, is that there are a lot of things that should be done, not only on the fundamental design of the software, but also on the usability in terms of SLAs, in terms of programming models. So what are the models that will allow us to get things like, backup, failure, what is the behavior of the software following a failure, and those kind of things. Looking at the various domains, you see that there is engineering, manufacturing, life sciences, geosciences, which is a very important domain, and here we talk about oil and gas customers, which is pretty important in terms of needs. I think I heard a speaker just before that was mentioning about reservoir simulation, And those kind of guys are one of the biggest demands that we have currently. Just to give you some example, all the big oil and gas companies in Europe, but in this region, Russia, Kazakhstan, and here, all the big ones are buying huge clusters. So if you look at Aramco, Total, if you look at Statoil, if you look at Eni, all these guys have more than a petaflop systems either coming or already in place. Okay? And that's a petaflop, right, that you need mostly for reservoir simulation, some other applications, but mostly reservoir simulations. Okay? You have a big component which is on the governance and classified. This is obviously a domain where the mathematicians are the happiest people because that requires a lot of intelligence and that's really encryption, decryption, secret services kind of stuff. But again, there is a big challenge in terms of big data. These people hold zillions of informations and you cannot imagine the number of Hadoop-like projects that we have, the number of opportunities that reside on the fact that they need to analyze more data in a single instance. I cannot name the customer, obviously these are very, how would I say, confidential customers. One of our customers is running a cluster that in size, and here I'm talking in number of racks, occupies half a football field. Okay, so that's the kind of size where our customers are currently spending their time, and this is to tell you that the big data challenge that they are having right now is one of the biggest issues they have. Okay, and we are there to say we can help. The financial services is a very interesting domain. This is obviously for well, a lot of risk management, making sure that they do not allocate credit to the wrong person and those kind of things. There's a lot of financial services requests currently going. And the media and entertainment finally is a very big demand that we have at HP. And also obviously because of all the security issues that you see with online videos, cameras, all the data that is being transferred over the web or from the internet. So this is to tell you that this market is huge. This market is huge. IDC estimates that this market for EMEA only is worth $3.5 billion. And that's a kind of statement where you can say, there's something there. If you look at it from another angle, HPC today, and that's IDC that states this figure, is using 1/4 of all the servers sold worldwide. So that means that 1 of each 4 servers sold on the planet is used for HPC. And that's increasing. It's moving towards 30 or 32% for 2014. And it is a very interesting, kind of topic. Obviously, I'm interested in terms of sales, but in terms of scientists and researchers, that also tells you that it is the domain in which you should be today. And by the way, don't hesitate to interrupt me, ask questions. I guess we can get some translation if you wish. So Volodymyr, if you are there, you can translate questions. Go ahead.
Let me ask you such a question. That's really important if 1/4 of the sold servers include data centers. But cloud data centers, are they included to HPC domain? Data centers.
What do you mean by data centers?
Data centers that serves for cloud computing and so on, not the systems entirely used for the impact.
So when I say 1 server for each 4 servers is sold for HPC, it is running on HPC clusters. Okay? The data center thing is something which is completely aside.
So this is a different story.
Only for HPC, that's 1/4 of all servers are being sold to HPC.
Yeah. Well, then it's really impressive.
Of course. And you can imagine. So this is the current position of vendors worldwide. Okay, and here that's an IDC classification, as you know. So HP is first, but for the highest ones, that's for IBM, which is in front. I guess here in the region you must have some other competition, obviously. I don't know whether you see so much of the other competitors. I don't know whether you see the local manufacturers or the Russian manufacturers around, but that's a worldwide figure, just to let you know that HP is pretty strong in this domain, and this year we will maintain our leadership. So we will be equal to IBM in terms of size this year. So what is our message today? The message is that we have barriers for innovation and scale. And here we say that sometimes the clusters don't perform as well they are expected to perform. And we see that so many times. The lean pack is working fine, but that from an application standpoint, the cluster doesn't work. It does not scale, it does not move ahead, it is not something which is really something that you can manage and run as per what you would like to. We also see the second issue, which is the power and cooling. Okay, and that's a well-known, I guess, I have a pointer? No, I don't have a laser pointer. So the power and cooling constraints that we are facing, and I don't know the price of energy here in Ukraine, but I know that for some customers, the TCO, the total cost of ownership for a cluster, roughly you would say that the price of the cluster is paid by an equivalent amount of energy and cooling over 3 to 4 years, depending on the cost of energy. So that really means that we have to do a better job at providing things which consume less power, or things which consume power in a more efficient way. Okay, so that's the challenges that we see. And the third challenge that we have is the infrastructure complexity. The more we go, the more we see clusters that cannot scale, that cannot move into something else. There were some presentations before. I think I heard NVIDIA being stated, I heard Xeon Phi, I heard, well, there are plenty of new technologies. The clusters that we are running today, that customers are telling us, I cannot change my infrastructure. The infrastructure is not flexible enough. I cannot adapt to the new Mellanox FDR switching. I cannot adapt because simply it is not meant to scale. So this is the third issue that we need to address. Okay? So to do that, we say we have a message. We say that we want to do faster solutions. The second one is obviously we wanted to do it better. We want to optimize. Okay? In all sense, and I will show you a little bit later how we optimize. And we want to do it in a smarter fashion. And you will see, and I guess we have a presentation Friday at the end of the day about a cluster management utility that we are using at HP. You will notice that we have put a lot of effort into manageability of clusters. And this is one of the ways that we want to solve these issues. So let's move on to a little bit more technical analysis. We are seeing the world of HPC changing since 2 or 3 years significantly. If you look at the charts on the left side, the mainstream Xeon traditional Intel or AMD solution was mainstream and no discussion. Everyone had to have an Intel or an AMD cluster. Since 2-3 years, you have seen on the right side NVIDIA and Xeon Phi, okay, also called Mike. So that's the old name, the new name being Xeon Phi, being adopted for the very high end. Okay, and this is something that is changing the environment quite drastically. And we have seen the change in terms of making sure that your applications are adapted, that they run on those new components. And second, the fact also that the power and cooling equation is different. Okay, so power and cooling constraints are very different. Now there is a third way of looking at the change in the HPC market, and it is the left side, which is the ultra-low power solutions, where HP has been developing some kind of early prototypes until last year, and a product now that could be used for some kind of HPC workloads. Not all of them. I mean, double precision is still in its infancy, but it is a process, okay? And to do that, we are delivering now products that are based on ARM or Intel Atom processor, and which is an ultra-low power solution. That means that in a single rack, it is not again about hosting tens of servers, 40 or more. It is about hosting thousands of servers in a single rack with those solutions. The performance is not as good as with a traditional Xeon-based architecture, but overall you will gain a lot by using ultra-low power. The issue, you might say, would be the programming model. Okay, you are scientists, you are designing applications. What's the programming model? I think Intel left their Studio Labs CD here, and if you look at the Intel Atom, it has exactly the same programming model. Okay, there's no change. So why not think of something which is really more aggressive in terms of power and cooling efficiencies for the future? So this is one of the directions that I will look at a little bit later. Okay? So we are providing now today, we do not make a choice, we do not say a solution is better than the other. We say, in a majority of cases, the mainstream Intel Xeon or AMD, well AMD is a little bit behind, but Intel Xeon way is the right way to handle your workloads. In many cases, and if you look at specific fields like oil and gas applications, some manufacturing applications, NVIDIA or Xeon Phi, we do not know about Xeon Phi, definitely, will be the right way to look at your workloads. However, there's also another way to look at the low power solutions that are provided, and this is something that I really encourage you to look at. It is something which is really interesting in terms of power and cooling efficiencies, and it is also a thing that will allow you to run the same application, right? No change to the application in this environment. Any question, by the way? Just looking at time, I'm doing good on time?
Yes, we shifted by the minutes.
Okay, so I have plenty of time.
Maybe a small question, if you could maybe elaborate a bit, or you were promising to elaborate on it a bit later. I mean, what do you mean by programming model? Do you mean a particular programming languages, or do you mean the model for people who write compilers, or for application programmers? What kind of model?
I really mean for the application programmers. I'm not meaning the people that write the compilers.
Okay.
But the application, at application level, you would only have to do a link with the libraries that are provided by Intel, and that would not change the application itself. Okay? And that is, for you scientists, it is not an issue. I mean, you are used to change environment and to port your applications based on the hardware, the underlying hardware. For most users, they don't care. They just want their ISV application to be running on their cluster, whatever the underlying infrastructure.
Thank you.
So, this is the first technology slide that I'm presenting. So this is the current product set that we have with our SLI, which is supporting, this is our Gen 8, by the way, product. It was released a few months ago. And this is the HPC specialized product that HP is providing. So this is a 4U chassis, which can include up to 8 servers, but can also run 2 servers with many GPUs. Okay? So it's either one server with no GPU for a total of 8 servers. You can also have 4 servers, which will be 2U half-width, each of them running 3 GPUs. And this is the one I guess you have here. That's the SL250 that you are running here. And you also have 2 servers, only 4U high, which can take up to 8 GPUs. And I guess this is unique. So if you have a case where you need plenty of GPUs, we now have a box which is able to run 8 GPUs in a single server. Okay? So what we are doing is that we integrate all these components, and that's HP is doing that everywhere. We integrate all those components at factory level. So that means that we do not deliver parts to our customer. That is something that we do. We always pre-integrate, pre-test the equipment that we are delivering. Okay? It's very seldom. Sometimes we do have customers that require that we deliver parts, but it is not a tradition at HP. Every year we deliver, in Europe only, we deliver about 300 clusters. So this year it will be 350 clusters. And a majority of those clusters are pre-integrated, pre-tested in factory and delivered finally to our customers. So that's one of the specialties that we have at HP. So this is the current product set that allows you to manage all the mainstream demos. Okay? Now let's move on to a complete portfolio look. So if you look at the servers on the innovation side, so we have all the traditional rack mounts or standalone servers. We have on the bottom side the partnerships with accelerators, so NVIDIA, Intel, others. Okay. We have the Mellanox InfiniBand products, knowing that QLogic has been bought by Intel, and QLogic roadmap is a little bit fuzzy for the time being, so mostly we are working with Mellanox. If you look at the upper right side, which is on the efficiency, you will see here that we have a lot of tools around rack and power management. So we have a lot of tools to manage at rack level the power efficiency, okay, of those tools. And on the right side, you have what we call the HP Pod. And this is a massive box. Massive, we have various sizes of it. It is a data center in a box. It is a container that allows you to host your environment into any place. So you put that on a parking lot, in any kind of warehouse, and run your application. So that means that you can run data centers without the need for a data center. And that's to answer your question on data center. In some cases, we do not, at no point do we need a data center, because we can deliver the boxes and the racks pre-integrated, just put it on the parking lot and run it. Okay? And we have also some tools, and that is on the agility side. So here you have just a very small description about the CMU, so that's our cluster management utility tool, that will be presented Friday by Sébastien Cavados from Renault. And we do have the expertise on applications, obviously, because we work every day with ISVs to optimize their code, to make sure that they are certified on our hardware, and this is something where we have considerable experience. Now, let's move on to the ultra-low power. So this is the announcement that HP made roughly a year ago, that we are going to implement a server based on ARM initially. And this box is a 4U box, basically, and each box contains up to 72 servers. And that's an ARM-based servers for the time being. So we have plenty of requests from customers which are now telling us how can we engage, how can we test it, how can we port